So for this final project, I'm doing it on an electrical resistivity survey in Fort Thomas, Kentucky. And the whole purpose of the study is just to try to detect landslides that are happening in this area. So my study area that I chose is in northern Kentucky. I chose that because of the high probability of landslides that happens here in this area. So you can see the distribution of landslides in Kentucky, and there's a high concentration of them in northern Kentucky specifically. So that's why I chose this area. And then this specific site location is in Fort Thomas, and I chose it because I had access to it, as well as you can see there's this big downward slope that's happening in this area. So from the road to the tree line, there's a pretty significant slope that happens pretty quickly, I would say. And so I thought this area might be, might have had some landslide activity in the past, or maybe some possible creep has happened. Once I actually got on site, you can see there's some pictures right here. I was looking at the tree line, and all the trees seem to be standing up fairly straight. So I kind of just thought that this indicated that there hasn't been any major mass movements in this area anytime recently. So when forming my hypothesis, I really focused in on trying to determine if there's going to be some level of creep that's going to show up. So for my methods, I measured out the area that I was going to lay my cables, and then I stuck the metal rods in the ground and laid out the cables in this configuration you can see right here. And I attached all the electrodes to the rods, and then after that I connected the cables to different equipment, such as like the switch box, the data system, the battery, the laptop. There's more detailed instructions as to what I did in my methods right here, and also if you look in my report, I have even further detailed instructions. So after that was all set up and I ran my survey, I was able to create a profile. So basically how I did this is I saved the measured data points from the survey to the computer, and then from the computer I was able to use the EarthMadger 2D software. So I uploaded my data that I had gotten from the computer onto the software, and then the software was able to interpret the data and created a profile. So the only thing that I really did to alter this profile to make it easier to read was I ran an inversion on it, and this led me to the profile that I have for my results, which is the STUD. This is what it looks like. So these results, they only really showed 3 different anomalies, which you can see here. The first anomaly has really high resistivity reading, which I thought was really interesting, and it has a very interesting shape along with it. And then there's these 2 anomalies, which, they kind of gave off readings in a similar range. And yeah, so from these results, I was able to interpret what I think they might be. So to help me do that, I used this chart, and I got this chart from the lecture slides from class, and I kind of concluded, I looked at this first anomaly first, and because of such high resistivity reading that I got, I concluded that it would be non-conductive, so it would have to be like a plastic or like a thermal coating or something, something that's not conductive. And because of that, and also the shape and like the consistency of the reading throughout it, I kind of thought this meant that it is man-made, so it's not something that was there by the earth. It's like something that was put there by a human. So because of those reasons, I interpreted this as being a PVC pipe, just because it also goes like straight into the ground, so that would make sense for like drainage purposes. And then for the second and the third anomaly on the side, they gave off similar readings in my results, so I concluded them as being like the same substance, which when you look over here, the readings that I got in the results were similar to like a sandstone or a conglomerate. And that would kind of make sense for this area. And also because of the shape, like conglomerates, they can be in these shapes, or like if you have like a chunk of sandstone, like it would make sense, especially from being weathered and eroded and being like pushed down a hill or something. Like this sphere shape, it would just make sense for it to be like that. And then lastly, the matrix. The readings that I got from the results were very similar to like a clay or a shale, which shows up over here. And so there's a clay, there's a shale, and these were also the lowest readings that we got on the resistivity profile. And this could be a result. It did rain the day before I went and took this survey, so that could have something to do with why these readings are so low. Like there could be some rain that is still suspended in this matrix. But I mean, the clay and shale, it makes sense for this area, so I think that's pretty solid. Next, so my conclusions after getting these results and interpreting everything is that there has not been any landslide or creep evidence. I think this because I was able to do some further research online, and I compared my profile to a profile that I found online, and they were also doing resistivity with landslide studies. So you can see on these profiles, this one, it's kind of small up here, but down here you can see like all of this green and blue. This is all from a landslide that's happened. So this landslide, it like completely took over this area. So this was like the old surface that was just like pushed over and buried by the new stuff, the new sediment from the landslide. So if you go back and we look at like what I had, it's all very uniform. Like there's no, weird 2 layers happening horizontally. It's all pretty much the same. This survey is also only 1 meter deep, so that could also have something to do with it. So yeah, I think like for further research, if I were to go back and do this again, I would also do ground penetrating radar survey, so a GPR survey. And this would allow me to, take data more easily at deeper depths. So this, I'd be really able to compare like the different layers and be able to look at how these different layers in the subsurface are lining up with each other. And I think that'd be really beneficial to compare to the electrical resistivity survey that I already have. So it could either, confirm my conclusion that there hasn't been any landslides or creep in this specific location, or maybe it could open up another door, say, hey, maybe there is some signs of it, I just didn't catch it on the ER survey. So lastly, I just wanted to thank the Kentucky Geological Survey because they provided the landslide distribution map that I had on one of my earlier slides. And then also the Nardina Research Group that I looked at to compare my profile to their profile to kind of help me, form my conclusions. And then I'd also like to thank Nilesh for just being a great professor and teaching this course and just being awesome all around. And then these are my references.